Welcome to the Human 5.0 Project, the podcast where we cut straight to the breakthroughs that matter, the show where science meets self-optimization. I'm your host, Ultimate Biohacker 10X, and here we break down the real research, real data, and real dosing behind modern biohacking, from compounds and peptides to techniques, devices, lifestyle strategies, and performance protocols. Most people jump in and jump out before they get the gold, so we're keeping it tight and delivering the essential insights you need without the fluff. If you've taken the time to hit play, we'll make sure you walk away with valuable knowledge that can transform your approach to longevity, health optimization, and beyond.
Hey loyalists, biohackers, and longevity rebels. Ultimate Biohacker 10X firing up the mic again. We are here to rewire your brain, ignite new synapses, and make every thought sharper than the last. So welcome back to the Human 5.0 Project, and tonight we are talking Dihexa, the angiotensin 4 analog that's earned a wild reputation online. You'll hear people call it neurogenesis on steroids. More accurately, it's synaptogenesis on steroids. Building connections, not necessarily growing brand new neurons. And yes, you'll hear the claim that in a lab neurotrophic assay, Dihexa showed activity 7 orders of magnitude stronger than BDNF. That number comes from early reporting around the compound's neurite synapse assays. Impressive, but remember, assay potency is not the same as real-world clinical potency. So is it hype or the real deal? Let's break it down raw. Origins, research, where it stands as of late 2025, early 2026, approval status, what we know about oral activity and half-life in animals, formulation headaches, and the big safety elephant in the room. Quick disclaimer, this is educational and not medical advice. Dihexa is not approved as a therapy and long-term human safety data is not established. If you've got a history of cancer, active malignancy, unexplained lumps, or you're skipping screening, this is not a pathway to casually play with. Dihexa is also known as PNB0408, a metabolically stable angiotensin 4 derived analog developed by researchers at Washington State University. It was designed to overcome the classic peptide problems: degradation, poor brain penetration, short duration. In the key mechanistic paper, Dihexa is described as orally active and blood-brain barrier permeable. Here's what makes Dihexa unique. It doesn't act like a stimulant. It's not dopamine juice. In the foundational work, Dihexa was shown to bind hepatocyte growth factor with high affinity and potentiate HGF activity at the c-Met receptor, and the pro-cognitive synaptogenic effects were linked to that pathway. Translation: Dihexa is basically an amplifier for a growth factor signaling system involved in synaptic plasticity, the brain's ability to strengthen and form connections. That's why the Alzheimer's angle took off. The animal evidence, what it shows, and what it doesn't. The why people care lane. Multiple animal studies report pro-cognitive effects in models of impairment in Alzheimer's-like deficits, with changes consistent with improved synaptic function. The it's not universal lane. Not every model shows a miracle. Reviews and later preclinical work highlight that results can depend heavily on the disease model and outcome measures. So the honest framing is, there is real preclinical signal, but it's not a guarantee across every neurodegenerative context. Oral activity and half-life, what's actually documented? Well, the peer-reviewed mechanistic paper describes Dihexa as orally active and blood-brain barrier permeable. A research summary used by Alzheimer's-focused reviewers reports a very long half-life in rats, about 12.68 days after IV and 8.83 days after intraperitoneal administration. That's unusual and partly explains why the compound has this one dose lasts forever mystique. But here's the key. Animal pharmacokinetics don't equal human pharmacokinetics. And it's not a clinical dosing blueprint. How about current status and approval? Let's make this crystal clear. No countries have approved Dihexa as a therapeutic drug. The compound is widely sold as research use only by vendors, and those disclaimers are explicit. Now the industry plot twist. A company called M3 Biotechnology was founded to commercialize the Dihexa science, and the clinical development narrative largely shifted toward related candidates in the same HGF c-Met lane, notably fosgonimeton, or ATH-1017. And this drug's phase 2 and 3 LIFT-AD trial did not meet its primary endpoint. and the key secondary endpoints, though subgroup and biomarker analyses were discussed. That doesn't disprove Dihexa, but it does kill the fantasy that this pathway automatically becomes a slam dunk human therapy. Why is reconstituting Dihexa a pain? Dihexa has solubility challenges, and in published animal pharmacokinetic work, it was dissolved using high percentage DMSO for administration. Now, DMSO can carry its own risks at high concentrations, and formulation choices can introduce confounders like irritation, impurity, transport, etc. Translation: the prep is not trivial, and the more complicated the prep, the more ways there are to do something unsafe. What we do know about current dosing in the biohacking community is the following. Most experienced users prefer oral administration of Dihexa, either in capsules or sublingually, as it is proven to be effective with good bioavailability and crosses the blood-brain barrier well. Real-world dosing this year is far lower than animal to human extrapolations, which suggest 10 to 20 milligrams per day because Dihexa is extremely potent. Common protocols include conservative nootropic stack at 5 to 15 milligrams once or twice per week, which would be the most common approach. Aggressive neural repair at 20 to 40 milligrams 2 to 3 times a week, and this would cycle 4 to 8 weeks on, followed by at least 8 to 12 weeks off to avoid potential overstimulation of the HGF c-Met pathway. While some users still inject Dihexa thinking it might be more effective, oral is proven insufficient. Injectin is not necessary and is generally discouraged unless there's a specific reason. If you do choose to inject subcutaneously or intramuscularly, note that Dihexa is almost insoluble in water or bacteriostatic water alone. The standard lab method is first dissolve the Dihexa powder in pure DMSO, typically 10 to 15 milligrams per milliliter, gently heating if needed, then dilute with PEG 300 and sterile saline, or just saline. A typical recipe for a 10 ml vial at 5 milligrams per milliliter would be 50 milligrams of Dihexa powder, 1 to 2 milliliters of pure DMSO, 2 milliliters of PEG 300, and 5% tween 80 for a smoother solution. You would top this off with bacteriostatic water or saline and then filter through a 0.22 micrometer sterile filter into a sterile vial. However, DMSO can cause significant stinging at the injection site and may carry impurities unless it's sterile grade. And this can go right into the bloodstream if you're not careful, so most experienced users just recommend avoiding injection unless absolutely necessary. Now for the part hype tends to skip. The pathway Dihexa touches, HGF c-Met, is involved in growth, survival, and cellular migration biology. That's exactly why researchers and Alzheimer's reviewers flag that long-term safety hasn't been adequately evaluated, including concerns that come up when you modulate growth factor systems. To say it plainly, this is not a casual daily vitamin pathway. If someone is high risk or has cancer history, this is where trust but verify becomes don't gamble. So here's the real 2026 takeaway. Dihexa is one of the most interesting synaptogenic research compounds we've seen. Mechanistically novel, orally active in animals, and with some impressive preclinical cognition signals. But it also carries a translation gap, limited clinical data on Dihexa itself, and a safety gap, growth factor pathway concerns, and no long-term human safety. So is this hype or the real deal? It's real preclinical science with real unanswered human questions. So for now, stay rewired, trust but verify, and stay synaptically sharp. See you soon.
Thanks for listening to the Human Upgrade Project. If you found value in today's episode, share it with someone who's ready to elevate their biology. Make sure to follow the show for weekly deep dives into peptides, protocols, devices, lifestyle strategies, and the science of high-performance longevity. Until next time, stay curious, stay optimized, and stay 10x.